In this video, I'll talk about application symptoms and response actions. An application usage baseline establishes what is normal for that application's usage, whether it's on a single server, multiple servers, or even its effect on the network. Once we've determined what's normal for a specific application, then we can easily detect anomalous activity. In some cases, applications spawn other background processes, and this could be legitimately a part of the app, or it could be a result of malware being triggered in the background. In some cases, failover clustering can be used to deal with application unavailability. Failover clustering means we've got two or more servers working together to offer the same service, and if one server fails, the other server or servers can pick up the slack. For failover clustering to be effective, all of the nodes in the cluster need to be using the same shared storage so that they have the same up-to-date data. User account activity, whether it's the creation of user accounts, modification, deletion, or usage, should be audited. Of course, we're going to have regular end user accounts for users to authenticate and access network resources, but some applications have background services that need a specific account to run. Now, we should follow the principle of least privilege when building these service accounts to only grant the privileges required and nothing more. But some operating systems like Windows will allow the creation of a managed service account. This is a secure practice because a managed service account can automatically change its password based on the domain password change interval. Whereas just building a dummy user account for the service requires administrators to change the password for that account periodically, hopefully, and not using a password that never changes for the service account. Malicious users might also build user accounts that look benign. It might be a normal looking username that doesn't stand out. And in fact, it might be used by the malicious user as a backdoor, and it might even have elevated privileges. So you might not notice this when you're just looking at user accounts, especially in a large environment with thousands of them. But if you're auditing this, you might notice that it's strange that at 3 o'clock in the morning in your time zone, a new user account was created, because that might not be normal. Applications should be thoroughly tested during development and testing phases for how they behave when they receive unexpected input, because that could result in unexpected output. Fuzz testing throws lots of random data that an app might not expect to observe its behavior to make sure it doesn't crash, reveal sensitive information, and so on. So sometimes specially crafted input in the form of website forms and certain data within fields or certain network packets sent to an app can cause it to reveal certain data that it shouldn't otherwise. So the transmission of private data to a third party might be revealed unintentionally. Or in the case of a ransomware infection, the host might periodically reach out over the internet and contact a command and control center where it receives instructions from the malicious user on how to proceed with encryption. Outbound firewall rules can also be very helpful. Everyone's concerned about inbound firewall rules, and certainly they're relevant. But also at the host level and network level, outbound firewall rules should track anomalous activity. Is it normal that we've got our hosts contacting a certain part of the world, which could be a command and control center location, for a hacker's server to receive instructions? Application service interruptions can also take the form of denial of service attacks or DOS attacks. A DOS attack essentially renders a system unusable for legitimate uses. It could be as simple as making a machine crash, or it could be flooding a machine with network traffic such that legitimate users can't even get in. Now, what do we do about that? If we've got a web server, we're not going to block port 80 because then legitimate users can't get into it. So there are many security solutions, even in the form of hardware appliances, that will look for irregular traffic flows, such as a lot of traffic coming from one host or a certain network within a short period of time, and simply block those hosts from communicating with the application. For example, a web app on port 80. Memory overflows are also called buffer overflows. So what can happen is we can grant a malicious user elevated privileges due to the fact that software might not be properly checking what's being fed into it. For instance, a web form with a field where a user puts in a lot of extra data that isn't being validated server-side could result in elevated privileges when that's sent back to the server. Or it could even corrupt memory in the application and freeze the application, or even cause the operating system to hang. Now, we're not going to run around to each and every host and check all of these things. Instead, we would use things like host-based intrusion detection systems or host-based intrusion prevention systems. There are also network counterparts that would be relevant if our application is distributed or has a lot to do with network traffic. Now, an intrusion detection system differs from a prevention system in that the prevention system can not only detect, log, and alert about suspicious activity, but a prevention system can also take steps to prevent it from continuing. Now, you might have to configure it specifically in your environment for your specific application, or over time, depending on the solution, it can learn what's normal, learn what's suspicious, and automatically make a decision by itself. In this video, we discussed application symptoms and response actions.